Video we will be constructing DFAs for these 7 languages, right? So what are these 7 languages? Okay, in this video we will be constructing DFAs for these 7 languages. Okay, so we have a set of L1, L2 and L3 languages, L1 and L2 and L3, which is built upon this alphabet 0 to 9, and L4, L5 and L6 is the strings of L4, L5 and L6 will be over the alphabet with symbols A and B, and similarly L7 will be on binary symbols 0 and 1. So it's clearly when the symbols are between 0 to 9, whatever the string is a decimal number, right? So a string can be interpreted or represented, can be thought of as a decimal number. So it's a decimal number, and when it is 0 and 1, you can say that it's a binary number, right? And it is A and B simply. Now when it's a decimal number, what we have to do here is we have to look whether the decimal number is divisible by 3, whether the decimal number is even, or whether the decimal number is odd right now. So let's construct the DFAs for these 3 languages first. Okay, let's take L1 first. So L1 is W such that W is divisible by 3. अरे क्या है? L1 is W such that W is divisible by 3, right? So and symbols are from 0 to 9. Now you know that if you divide any number by 3, the remainders are 0 or 1 or 2, right? So if you take any number, then what would be the remainder? So if it is 0 or 3 or 6 or 9, because this is what the symbols. What are the symbols? Symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 0, 3, 6 and 9, the remainder will be 0. 1, 4 and 7, the remainder will be 1. When 1 or 4 or 7 is divided by 3, the remainder is 1. When 2 or 5 or 8 is divided by 3, the remainder is 2. So we can represent this L1 we can represent L1 with a deterministic finite automata. How? So if we have 3 states, let's say this is your 3 states. If you have 3 states such that each state represents what the remainder would be. Okay, so this represents Q0 represents remainder 0. Okay, and Q1 represents remainder 1 and Q2 represents remainder 2. So, okay, if I take the initial state would be Q0. Okay, if you are at Q0, because Q0 represents remainder to be 0, it means this string is divisible by 3 when the remainder is 0. So you make Q0 as the final state also. So when you have 1 minute, okay, so if you get 0 or if you get 3 or if you see 6 or 9, it is still divisible by 3, so you will stay at Q0. Now if you see 1 or 4 or 7, the remainder should be 1, so it goes to Q1 and Q1 represents remainder 1. Similarly, from Q0, if you see 2, 5 or 8, then you should go to Q2. Because Q2 represents remainder 2. So for Q0, the moves are defined. For Q0, all possible moves are defined. That the catch is how you will define the transition for Q1 and Q2. That's the catch. How you will define the transition for Q1 and Q2. That's the catch here. Okay, very good. So when you are at Q1, Q1 represents remainder 1. Q1 represents remainder 1. So when you are at Q1, it means that the string traversed so far gives the remainder 1 when it is divided by 3. So you can say that Q1 is 1 mod 3 and Q2 is 2 mod 3 and Q0 is 0 mod 3. Okay. So now what you are going to do is you will be using your knowledge of modular arithmetic in giving the transitions. Right? You will be using your knowledge of modular arithmetic to define the transitions. And what is that? So, okay, 1 minute. You see, in modular arithmetic, if you have a number, let's say a b mod n, then it is same as b plus n mod n. It is same as b plus n mod n, right? For example, 5 gives, for example, 5 gives the remainder 2 when you divide it by 3. 5 gives the remainder 2 when you divide it by 3. If you add 3 to 5, okay, 5 mod 3 is what? 2. What is 8 mod 3? It is also 2. So if you add n to the number, the remainder does not change. So can I say that if I put 0 or 3 or multiples of 3, if you put here a is same as b plus 2n mod n, so on, it is same as b plus nk mod n. And this is just you are using your knowledge of modular arithmetic. And okay, if you don't know modular arithmetic, then you deserve, if you are at this stage and you don't understand this thing, it's so basic, then you deserve something with just wait, I'm showing that. So we will use this example. Okay, so you understand this. Similarly, 0, 3, 6 and 9, it will stay at this. The remainder would, if you are at Q2 and the next symbol is one of 0 or 3 or 6 or 9, then the remainder will still be 2, so you stay at Q2. Okay. Similarly, if you are at any state, similarly you can say that if the remainder is 1, what are the symbols? If the remainder is 1, when the remainder will become 2? when it is 1 of 1, 4 or 7. So from Q1 if you go to Q2, you will go to Q2 on seeing 1, 4 or 7. Okay. What about when you are at Q, and if you see 2 or 5 or 8, when you are at Q1, the remainder is 1. The remainder is 1. And if you see 2 or 5 or 8, where you should go? You should go to Q0, because then it will be divisible by okay. When you are at Q2, the remainder is 2. So when you see 1, 4 or 7, it will be divisible by Q0. 1, 4 or 7, it will be divisible by Q0. So sorry, it will be divisible by 3. So you will go to Q0. When you are at Q2, the remainder is 2. And if the next symbol is 2 or 5 or 8, so remainder is 2. 2 plus 2 will be 4. So remainder will become 1. So on 2 or 5 or 8, you should go to Q1. 2, 5 or 8, you should go to Q1. Okay, if you cannot wrap your head around this thing right now, so let me give a very simple explanation to this, and you will understand that clearly. Those who have already understand, then you don't need to look at the next 1 minute or so. Tell me about this. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. This is all of this is multiple of 3, right? Okay. 1, 2. Okay, 1 minute. 1, 4, 7, 10, 13, 16, 19, 22, 25, 28, 31. What is this? All of this, when you divide by 3, it will give remainder 1. And if you see 3 was divided by 3 gives the remainder 0 when divided by 3. So if you add 3 to it, still the remainder is 0. You add 3 to it, still the remainder is 0. So you add 3 to anything, the remainder does not change. If the remainder was 0, it will be 0. If the remainder was 1, it will remain 1. Similarly, if you have here 2, 5, 8, 11, 14, 17, 20, 23, 26, 29, 32. So remainder was 2, and you add anything to this. If you add a multiple of 3, the remainder will remain 2. Remainder was 1. If you add a multiple of 3, the remainder will be 1. Remainder was 0. If you add a multiple of 3, the remainder will remain 0, whatever the number is. That's it. This is what this is it. Okay. W is an even number. Let's take up L2. L2 is W such that W is a even number. W is an even number. W is an even number. Okay. So you are at Q0. Summation is from 0 to 9. So you are at Q0 when you see, okay, 0, 2, 4, 6, 8. This is even. 1, 3, 5, 7, 9. This will be odd. So initially you are at Q0. If you see 0 or 2 or 4 or 6 or 8, you go to Q1. And Q1, it means Q1 is an even number. So Q1 represents Q1 represents even number. Oh, we should draw a. We should try to draw a minimal DFA in the first row. Okay, when we are constructing DFA, we should intuitively try to draw DFA for. We should intuitively try to draw minimal DFA. Okay, so let's say this is Q0. Q0 represents even number. Q0 represents even number. So anything 0 or 2 or 4 or 6 or 8 comes, it stays at Q0. Now from Q0, so Q0 represents even number means it is 0 mod 2. Now to 0 mod 2, if you get 1 or 3 or 5 or 7 or 9, you will go to Q1 and it is what? It is 1 mod 2. Of course, when you divide a number by 2, the remainders, so divide a number by 2, dividing a number by 2, remainders are 0 and 1. So Q0 represents 0 mod 2, Q1 represents 1 mod 2, so Q1 represents odd number. Q1 represents odd number. Okay, very good. Now when you are at Q1, now the remainder is 1. Now the remainder is 1. If you add another 1 to it, the remainder becomes 0. So on 1 or 3 or 5 or 7 or 9, it goes back to Q0. Right? Very good. Similarly, on 0 or 2 or 4 or 6 or 8, the remainder remains 1. So this is your DFA for L2. What is L3? W is an odd number. Okay. Yeah, W is an even number when Q0 is a final state. If you have to make W to be an odd number, this DFA, same DFA would be used, but Q0 will be non-final. 1, 3, 5, 7, 9. Make Q1 as final. Then it will give W to be odd. Then it will accept when W is odd. Okay. Good. Now come to this part. L4. Number of A to be 1 mod 3. L4 is W says that number of A's in W is equal to 1 mod 3. 1 mod 3. So here summation is A and B. So you are counting on number of A. So initially when you are at Q0, if you see A, so number of A seen is equal to, so when you are at Q0 you have not seen any symbol. You have not seen any symbol. So number of A seen is equal to 0. Number of A seen is equal to 0. What is the remainder? It is 0. It is 0. So Q0 represents number of A's 0 mod 3. And Q1 represents 1 mod 3. Okay. If you see another A, then this is 2 mod 3. Zero mod 3, 1 mod 3, 2 mod 3. That's it. That's it. When there is a number and you have to divide a number, you can represent if you have a number n, if you have a number n, the remainders would be from 0 to n minus 1. So when you are dividing by 3, the remainders would be 0 or 1 or 2. Q0 represents remainder 0, Q1 represents remainder 1, and Q2 represents remainder 2. Okay. Now when you are at Q2 and if you see another A, then you should go to Q0, because now the number of A becomes 3. Okay. We have no concern about B. If you look at this, the transition is defined on every state. What happens when that state, if the next symbol, what happens when you are at that state and the next symbol is A, what happens? You have defined that for every state. Now when it comes to B, it's none of your, it's nothing. When it comes to B, it does not matter. So when you are at B, for every state you can stay there. You can stay there. You can stay there. So this is what the DFA for L4 is. What do we want? We want 1 mod 3. So we make Q1 to be the final state. L5, 0 mod 2. Length of W has to be equal to 0 mod 2. Sorry. Length of W is equal to 0 mod 2. So L5 is such that W such that length of W is equal to 0 mod 2. Okay. 0 mod 2. When you divide a number by 2, remainders can be 0 or 1. So Q0 represents 0 mod 2 and okay, 1 minute. If you see A or B, what is the length of the string so far? Length of the string is 1, which is 1 mod 2. This is Q1. From Q1, if you see another symbol, the length becomes even. So you go back to Q0, A comma B. This is Q0 and this is Q1. You want the length to be equal to 0 mod 2. You make Q0 as the final state. This is the DFA. So giving DFA is easy if DFA is possible. L6 is W mod W is equal to 0 mod 2 or mod W is equal to 0 mod 3. Okay. L6 is W such that mod W is equal to 0 mod 2 or mod W is equal to 0 mod 3. Okay. What we are going to listen, this is a okay. I will construct DFA for this in while. Okay, let me give you a hint. Take this as L1. Take this as L. Okay, 1 minute. I should not have taken this example here. Let's say this is L dash. Let's say this language is L0, L02, and let's say this language is L03. Okay, then you construct a DFA for L02. That is possible. We have seen how to construct. You know how to construct DFA for L02, and you know how to construct DFA for L03. So let's construct a DFA for L02. As simple as that. A or B, you go to this. A or B, you return to this. This is Q0, this is Q1, and Q0 is the final state. Similarly, here it will be, make it Q0 2, Q1 2, Q0 3. Okay, Q03, when you go to A or B, you get to Q01, remainder 1. If you get another A or B, then the length of the string is 2. So this is Q. This goes to a state that represents 2 mod 3. So when the divisor is 3, the remainders are 0, 1 or 2. So we have got those states. Now from Q1, from if you get when you are at Q02 and if you get another A or B, another length, means if you get another symbol, then it has to be divisible by 3. So you go back to Q03. So this is A and B. So this is your M1, which is M for L02, and this is your, let's say, M2, which is your machine for L03. This is your M2, which is your machine for which is your machine for L03. Okay. Now you will, in future, you will see a video on the operations on regular languages, because L02 and L03 are regular languages. So L02 union L03 is also a regular language, and its DFA is given by the cross product of these two. Okay, so cross product of these two. So what are the states here? It is Q02, Q12. The states here is Q03, Q01, Q02. So the states in the DFA for L02 union L03 will be Q02, Q03, comma, Q02, Q01, comma, Q02, Q02. What the heck? I'm sorry. Oh. If it, okay, listen, I will continue from here. For this, if this DFA gets confusing, don't worry. Then I will study, when we will discuss the union operation, so intersection operation, complement operation, all that. I will revisit. Okay, I will take it one second because I have messed it up here. I think so. So I will take this example again. Q03. Okay, just leave it. I will take this example. Okay, now let me complete it. Q03, Q13, Q23. Okay. So the number of states in this DFA would be Q02, Q03, Q02, Q13, Q02, Q23, Q02, Q12, Q03, Q12, Q03, Q12, Q13, Q12, Q23. So these are the, so there will be 6 states. There will be 6 states. So, and in those 6 states, what is going to be the, what are going to be the final states, which is, because here it is OR, so the final states would be in it. You see where there is Q02 or Q03, you will have all of them as final state. So this is going to be a final state. Okay, Q02 is here, so this is also a final state. Q02 is here, so this is also a final state. And similarly, Q03 is here, so this is also a final state. So there is going to be 4 final states in your DFA. Should I make a DFA for it? Should I make a DFA for it? Listen, I will unnecessarily confuse you, okay? Because I have introduced this. Listen, if you can directly make a DFA without going into breaking like this, breaking into language L02, language L03, and then combining, because this I should have done it in the union section when I would be making a video on union of regular languages. Then I should have used this approach, okay? But honestly speaking, I solved this using this approach only. I could not. Okay, so L6 is W such that length of W is equal to 0 mod 2 or 0 mod length of W is equal to 0 mod 3. So just think you have not heard. Okay, so what? Okay, so so rather than having this approach, what you could do is you should go and directly solve for L6. You should go and directly solve for L6, and you will find that it is not so easy. You will not find it so easy to solve it. You will not find it so easy to solve it. Okay, because you will have to take into considerations of many possibilities, whether the length of the string so far is a multiple of 2, or it is, if not, then is it a multiple of 3. So you have to consider all those situations, and things will get complex, and you may commit a mistake in doing so. So we will look at this language when we will read about the union. That would be better. Rather than taking it right now. That would be better.